Hello viewers, welcome back to our channel Career Prep. Today we'll solve a few more problems under the topic Surds. Surd problems are very commonly asked in competitive exams. So understand and practice as many problems as possible. Before we begin, please subscribe to our channel. Also press the bell icon to get notifications as soon as we post a new video. So let's start. What is the product of square root of 2, cube root of 3 and sixth root of 5? So we have to find out square root of 2 multiplied by cube root of 3 multiplied by sixth root of 5. We know that square root of 2 can be written as 2 raised to the power 1 by 2. Cube root of 3 can be written as 3 raised to the power 1 by 3. And sixth root of 5 can be written as 5 raised to the power 1 by 6. So now we have 2 raised to the power of 1 by 2 multiplied by 3 raised to the power of 1 by 3 multiplied by 5 raised to the power of 1 by 6. Now, to find the product of these three numbers, you have to make the powers the same, which will help you to simplify the question. So, to make the powers the same, you have to find the LCM of the three powers, that is 2, 3 and 6. The LCM of 2, 3 and 6 is 6. Now the powers can be written as 1 by 2 can be written as 1 multiplied by 3 divided by 2 multiplied by 3, because you are making since the LCM is 6, you are making the denominator as 6. So 2 multiplied by 3 is 6. So numerator also you have to multiply by 3. Similarly, 1 by 3. 3 you have to make it as 6. So you are multiplying by 2. 3 multiplied by 2 is 6. Multiply the numerator also by 2. 2 multiplied by 1 is 2. Similarly, 1 by 6. 6 multiplied by 1 is 6 and 1 multiplied by 1 is 1. So now you have the powers as 3 by 6, 2 by 6 and 1 by 6. Now the question can be rewritten as 2 raised to the power 3 by 6 multiplied by 3 raised to the power 2 by 6 multiplied by 5 raised to the power 1 by 6. Now the power 3 by 6 can be written as 3 multiplied by 1 by 6. 3 multiplied by 1 by 6 is nothing but 3 by 6. So now you have 2 cubed the whole raised to the power 1 by 6. Similarly, 2 by 6 can be written as 2 multiplied by 1 by 6. 2 multiplied by 1 by 6 is nothing but 2 by 6. So 3 raised to the power 2 by 6 can be written as 3 squared the whole raised to the power 1 by 6. And 5 raised to the power 1 by 6 can be written as it is. So now you have 2 cubed raised to the power 1 by 6 multiplied by 3 squared raised to the power 1 by 6 multiplied by 5 raised to the power 1 by 6. 2 cubed is 8, 3 squared is 9. So now you have 8 raised to the power 1 by 6 multiplied by 9 raised to the power 1 by 6 multiplied by 5 raised to the power 1 by 6. Now the powers are the same. It is 1 by 6 for all the three numbers. So you can take out the common power. Then you can write this expression as 8 multiplied by 9 multiplied by 5 the whole raised to the power of 1 by 6, since 1 by 6 is the common power. Now 8 multiplied by 9 multiplied by 5 is 360. So you finally have the answer as 360 raised to the power of 1 by 6. 360 raised to the power of 1 by 6 is the answer. Which is the smallest among square root of 3, cube root of 2, sixth root of 5 and fourth root of 4? You have to find out which of these four numbers is the smallest. Now you know that square root of 3 can be written as 3 raised to the power of 1 by 2. Cube root of 2 can be written as 2 raised to the power of 1 by 3. Sixth root of 5 can be written as 5 raised to the power of 1 by 6. Fourth root of 4 can be written as 4 raised to the power of 1 by 4. But since here all the powers are different, you will not be able to find out which of the numbers is the smallest. So first make the powers the same. To do that, find the LCM of the powers. LCM of 2, 3, 6 and 4 is 12. Now you can write the powers as 1 by 2 can be written as 1 multiplied by 6 divided by 2 multiplied by 6. You have to make 2 as 12. Since the LCM is 12, you have to make 2 as 12. So multiply 2 with 6. Multiply the numerator also with 6. For 1 by 3, you have to make 3 as 12. So multiply 3 with 4. Multiply the numerator also with 4. Now for 1 by 6, you have to make 6 as 12. So multiply 6 with 2. Multiply the numerator also with 2. For 1 by 4, multiply 4 with 3 to make 4 as 12. Multiply the numerator also with 3. So now you have the powers as 6 by 12, 4 by 12, 2 by 12 and 3 by 12. So the numbers now become 3 raised to the power 6 by 12, 2 raised to the power 4 by 12, 5 raised to the power 2 by 12 and 4 raised to the power 3 by 12. Now 6 raised to the power 3 raised to the power 6 by 12 can be written as 3 raised to the power 6 the whole raised to the power 1 by 12. Since 6 multiplied by 1 by 12 is nothing but 6 by 12. Now 4 by 12 can be written as 4 multiplied by 1 by 12. So this number can be written as 2 raised to the power 4 the whole raised to the power 1 by 12. 2 by 12 can be written as 2 multiplied by 1 by 12. So this number can be written as 5 squared the whole raised to the power 1 by 12. 3 by 12 can be written as 3 multiplied by 1 by 12. So this number can be written as 4 cubed raised to the power 1 by 12. Now 3 to the power 6 is 729. So this number becomes 729 raised to the power 1 by 12. 2 raised to the power 4 is 16. So this number becomes 16 raised to the power 1 by 12. 5 squared is 25. So this number becomes 25 raised to the power 1 by 12. 4 cubed is 64. So this number becomes 64 raised to the power 1 by 12. Now the powers of the four numbers are the same. So compare the bases. When you compare the bases, clearly 16 is the smallest. So 16 raised to the power 1 by 12 is the smallest. This is nothing but the number cube root of 2. So cube root of 2 is the smallest among the four given numbers. Hope you have understood the method. You have to follow the same method if you are asked to, instead of finding the smallest number, if you are asked to find the largest number among the four, you have to follow the same procedure. Only in the final step you have to find out which is the largest number. The procedure is the same. The method is the same whether you are asked to find the smallest number among the four or the largest number among the four. The method is the same. Root 7 plus root 5 divided by root 7 minus root 5 plus root 7 minus root 5 divided by root 7 plus root 5 is equal to how much? You have to solve this equation to find the answer. You are given four answer options and you have to select which of the answer options is correct. Now to solve the equation, you have to first add these two terms. To add these two terms, you have to find the LCM first. The LCM is written in the denominator as root 7 minus root 5 multiplied by root 7 plus root 5. So in the numerator you will have root 7 plus root 5 multiplied by root 7 plus root 5 plus root 7 minus root 5 multiplied by root 7 minus root 5. So this can be written as root 7 plus root 5 the whole squared plus root 7 minus root 5 the whole squared divided by 7 minus 5. How did you get this 7 minus 5? Look at the LCM. Root 7 minus root 5 multiplied by root 7 plus root 5 is similar to a minus b multiplied by a plus b, which is a squared minus b squared. So this will be root 7 squared minus root 5 squared. Root 7 squared is 7 minus root 5 squared is 5. So you got 7 minus 5 in the denominator. Now observe that in the numerator, root 7 plus root 5 the whole squared is similar to a plus b the whole squared, which is a squared plus b squared plus 2ab. And root 7 minus root 5 the whole squared is similar to a minus b the whole squared, which is a squared minus b squared minus 2ab. So when you expand the numerator, you will get 7 plus 5 plus 2 root 35 plus 7 plus 5 minus 2 root 35 divided by 2. 7 minus 5 is 2, so the denominator is 2. Now 2 root 35 and minus 2 root 35 will cancel out. So you are left with 24 divided by 2, which is nothing but 12. So the correct answer is option B, 12. If x is equal to 5 plus 2 root 6, then find the value of root x minus 1 divided by root x. You are given 4 answer options and you have to select which of the options is correct. Now we have to find the value of root x minus 1 divided by root x. Now first you have to square this expression. When you square this expression, you will get root x minus 1 upon root x the whole squared. This is similar to a minus b the whole squared, which is equal to a squared plus b squared minus 2ab. So root x minus 1 upon root x the whole squared will be x plus 1 upon x minus 2 multiplied by root x multiplied by 1 upon root x. which is nothing but x plus 1 upon x minus 2. Now you know that x is equal to 5 plus 2 root 6. This is given in the question. So substitute the value of x in the expression x plus 1 by x minus 2. So now you will have 5 plus 2 root x plus 1 divided by 5 plus 2 root x minus 2. Now rationalize this denominator. To rationalize the denominator of the fraction 1 divided by 5 plus 2 root x, you have to multiply both the numerator and the denominator with 5 minus 2 root x. So now you have 5 plus 2 root x plus 1 upon 5 plus 2 root x multiplied by 5 minus 2 root x upon 5 minus 2 root x minus 2. Now when you simplify this, you will get 5 plus 2 root x plus 5 minus 2 root x divided by 25 minus 24. How did you get this 25 minus 24? When you rationalized here, you have 5 plus 2 root x multiplied by 5 minus 2 root x in the denominator. Now this is similar to a plus b multiplied by a minus b, which is a squared minus b squared. So this will be 5 squared minus 2 root 6 the whole squared. 5 squared is nothing but 25. 2 root 6 the whole squared is 4 into 6, that is 24. So 25 minus 24 minus 2. Now simplify this further. 25 minus 24 is 1. So this expression can be written as 5 plus 2 root 6 plus 5 minus 2 root 6 minus 2. Now 2 root 6 and minus 2 root 6 will cancel out and you are left with 5 plus 5 minus 2, which is nothing but 8. So the correct answer is option C, 8. If x equals root 11 plus root 20, y equals root 15 plus root 17, and z equals root 14 plus root 18, then which of the following holds true? You are given 4 answer options and you have to find out which of these options is correct. To do that, you have to first square and simplify the 3 given equations. So now you have x squared is equal to root 11 plus root 20 the whole squared. This is similar to a plus b the whole squared, which is a squared plus b squared plus 2ab. So now you have root 11 the whole squared plus root 20 the whole squared plus 2 multiplied by root 11 multiplied by root 20. This is nothing but x squared is equal to 31 plus 2 root 220. Similarly, y squared is equal to root 15 plus root 17 the whole squared. This can be expanded as root 15 the whole squared plus root 17 the whole squared plus 2 multiplied by root 15 multiplied by root 17. So you get y squared is equal to 32 plus 2 root 255. Similarly, z squared is equal to root 14 plus root 18 the whole squared, which can be expanded as root 14 the whole squared plus root 18 the whole squared plus 2 multiplied by root 14 multiplied by root 18, which is nothing but z squared is equal to 32 plus 2 root 252. When you observe x square, the value of x squared, y squared and z squared, it's very clear that x squared is the smallest and y squared is the largest. So x squared is less than z squared is less than y squared. So x is less than z is less than y, which is option D. So the correct answer is option D. X is less than z is less than y. If x is equal to square root of 196 plus square root of 200, then find the value of x by 2 plus 2 by x. You are given 4 answer options and you have to find out which of these options is correct. Now you are given that x is equal to square root of 196 plus square root of 200. Square root of 196 is nothing but 14. Now 200 can be written as 2 multiplied by 10 multiplied by 10, which is nothing but 10 root 2. So square root of 200 is 10 root 2. So finally you have x is equal to 14 plus 10 root 2. Now you are asked to find the value of x upon 2 plus 2 upon x. Now you know the value of x as 14 plus 10 root 2. Now we'll substitute the value of x in this expression. So x by 2 can be written as 14 plus 10 root 2 divided by 2. Now 14 divided by 2 is 7. 10 root 2 divided by 2 is 5 root 2. So x divided by 2 is 7 plus 5 root 2. Now substitute the value of x in the fraction 2 upon x. So you have 2 upon 14 plus 10 root 2. Now 2 divided by 14 is 1 divided by 7. 2 divided by 10 root 2 is 1 divided by 5 root 2. So you have 2 upon x is nothing but 1 divided by 7 plus 5 root 2. Now rationalize the denominator. To do that you have to multiply this fraction with 7 minus 5 root 2. You have to multiply both the numerator and the denominator by 7 minus 5 root 2 to rationalize the denominator of this fraction. So you will have 7 minus 5 root 2 divided by 7 plus 5 root 2 multiplied by 7 minus 5 root 2. Now this expression is similar to a plus b multiplied by a minus b, which is a squared minus b squared. So you get 7 squared minus 5 root 2 the whole square. 7 squared is 49 minus 5 root 2 the whole squared is 50. So in the denominator you will get 49 minus 50. Numerator is 7 minus 5 root 2. 49 minus 50 is minus 1. So now you have 7 minus 5 root 2 divided by minus 1. Since the denominator has a negative sign, this fraction can also be written as 5 root 2 minus 7. So x by 2 plus 2 by x can be written now as 7 plus 5 root 2 plus 5 root 2 minus 7. We found the value of x by 2 as 7 plus 5 root 2. 2 by 6 is nothing but 5 root 2 minus 7. So x by 2 plus 2 by x can be written as 7 plus 5 by 2 plus 5 root 2 minus 7. 7 and minus 7 will cancel out. When you add these two, you will get 10 root 2. 10 root 2 is nothing but 2 root 50. How? You can write 50 as 5 multiplied by 5 multiplied by 2. Now you can remove the common factor 5 outside. Then it will be 10 root 2. So 10 root 2 can also be written as 2 root 50. So the correct answer is option C, 2 root 50. Viewers, please go through this video till you have understood how to solve these important types of Surd problems. Since problems on Surds are very frequently asked in competitive exams, practice as many problems as possible to be thorough with the methods and also to increase your speed. Watch our next video to learn about number series, a very important topic. If you have liked this video, please like, subscribe and share this video. Thank you.